So we talked about USB as one of our most common types of peripheral devices that we're going to be using. So now we're going to talk specifically about different USB types. If you've done anything with computers, you've used some sort of USB device. There was a time when we had older interfaces where we had serial and parallel interfaces that could only support one device per port. If you wanted to connect two printers, you needed to have two parallel ports, which would be cards on the back. And if you wanted to a printer and a scanner, you would need 3 ports. So a USB eliminated the need to have a dedicated port for each connected device. It is designed to support multiple devices. One single bus can support 127 different devices, and I'll kind of talk about how they do that. So here are our key terms of bus-powered, hot plugging, self-powered, and USB. So USB is probably one that you've heard about. Have you heard of hot plugging? Self-powered? I'm sure you probably have. Have you ever seen devices that when they plug in via USB, that's when it gets its power? They can actually power it from the computer. That's going to be our self-powered. So here's our terms. So a bus-powered is a device that runs on power or receives from another device through a USB port. Hot plugging is adding or removing devices to the system without rebooting it. So for example, you plug something in, it's there, it recognizes, you eject it, and you don't have to restart your computer. And then a USB is our most common interface. So here is a typical design where we have our 3 common devices, keyboard, mouse, and a printer connected via USB. So how can we connect 127 devices to one computer? A USB can support 5 tiers of hubs. This structure is called a tier star topology. Each tier has a central connecting point where all devices connect, and the root hub is the base. A single hub can have 1 or more USB ports. The primary hub is that all other connected to is called the root hub. This hub is integrated with the USB controller host on the motherboard. So on this example, we have the root hub, which we can connect and say has 8 ports to this root hub. We can connect a second USB to that hub and so on, and the USB can support 5 tiers of hub. It's also called a tiered star topology. One thing to note about USB is that each hub, including the root hub, counts as a device. This means they can count towards the 127 connected devices, and that's okay because you're probably never going to need 127 devices connected to one port. That's a lot. You do need to be careful about bandwidth because it's shared among all devices connected to the same hub. That means the more devices you connect to a bus, the slower each device is going to operate. With only 4 or 5 devices connected, you probably won't see any performance issues, but if you start connecting a lot of devices, you might notice that they're going to operate a little bit slower. The main thing to know is the more USB devices you connect to a single bus, the slower overall operating speed you're going to see. Has anyone ever noticed that if they have a lot of things plugged in USB? That's good, good, good. So, since USB has been developed, there has been lots of different versions of USB. The main thing you know is that the different versions is their data rates. And note that USB cables used to connect devices also have a version association. So that means you can't connect a USB 2 device using a USB 1.1 device. You'll be limited to the cable's slower data rate. So first we're going to talk about version 1.1. It was the first version. It's very low bandwidth, and it runs at 1.5 megabits per second. The second is the full bandwidth that runs at 12. In today's world, these speeds are really, really slow for everything that we're doing. So transferring large files at this pace takes a very long time. So then we came about with USB 2.0. An example of how I do this is, for example, I have a big digital camera, and I will take the memory card out, and I would plug it into a multi-card reader. And if that cable is a slower cable speed, it's going to take a lot longer for those files to transfer over. But I don't have anything at USB 1.1. So in 2000, USB 2.0 was released, and it offered main increases in speed. It's often referred to as high-speed USB and is used quite frequently today. Most USB ports that you see in computers nowadays are 2.0. It has a maximum data rate of 480 megabits per second and a transfer rate that is much faster than USB 1.1. USB 2.0 is backwards compatible, which means you can use it with 1.1 devices, but 1.1 devices cannot be used with the 2.0 because they can, but you're going to be limited by the 12 megabits per second rate. And then in 2008, USB 3 came along. It's sometimes called super speed USB. It has a big increase in speed over previous versions, maximum data rate of 5 gigabits per second. You're going to see that your 3.0 devices and cables and ports are easy to identify because they have blue connectors. Have you ever noticed that? Some are white and some are blue. So anytime you see blue, you're going to know that that's going to be a 3.0 connector. And we do have 3.0 as an enhanced to 3.1, which again is just going to increase your data rates up to 10 gigabits per second. USB ports are so helpful. So there's many different types that you can plug and play. There's the standard A, or Type A, and the original USB port. The Type A end of this connector generally plugs into the computer itself, and then you also have your mini Type A's and your micro Type A's. Type B connectors are going to be at the other end of the cable that plugs into the peripheral of the device. And again, you're going to have your mini, your micro, all of those. So if a connector was ever lost or damaged, you'd want to rearrange your connection structure. It was impossible to do anything without buying a brand new connector for each device. So going through and using these types of standard cords makes our lives a lot easier. Anyone in here have an Android phone? Okay, do you have a newer one? Does it use the same charger as your Chromebooks? Did they charge faster on the Chromebook charger than your home charger? They do. That's because it's the connector on there. The other way that you have is, for example, I have a USB-C to USB-C cord. So they're actually two both ends, and it doesn't go to USB. And these are going to charge your devices a lot faster than the ones that go USB to USB-C. So, and it's much nicer that we have those options, too, instead of having to have something specific. I don't know about you, but in our household, we have a drawer of all of these different cords that you've got to try to figure out like what it works to and what it doesn't work to. Mm-hmm. So I would always go through and like take tape and try to label it, even like power cords too, because they have all those different connectors. So again, these are all the different USB types, and so hopefully you've seen some of those before. And so here's our USB Type-C. In 2014, they published the USB Type-C specification. Its main goal was to create a universal USB type so nobody had to own those 100 different types of cables. Okay, Type-C is simpler than previous types. Both ends of Type-C connectors are the same, no Type A and no Type B on the other end, and the cord allows bidirectional power flow. So a host device can charge the peripheral, and the peripheral can charge the host. The best part is you don't need a specialized connector for each pair of devices. All ports Type-C and one connector will work for all ports, even the Thunderbolt ports and newer devices. So here's an example of an Amazon that has C to C. And then we'll take a look at a couple cool features that you should know about is the ability to connect and disconnect when the device is powered on. That is called hot plugging. A second feature you should be aware of is this ability to power over the connection. USB devices can receive up to 500 milliamps of power from a USB 2 port and 900 milliamps of power for a USB 3. And remember, 3 is the blue one. If this amount of power is sufficient for the device, it's considered a bus-powered device, and it means it doesn't have to be plugged into something else. If it needs more power than this, it's considered a self-powered device and will typically have an external power adapter that plugs into the wall, like that KMVM switch where we had to plug it into the wall. So we're going to install a USB device. Now, one of the things that we need to think about when we install a USB device is we have to think about what you have to do to take it out. Have you ever plugged in a flash drive? What do you need to do before you pull it out? Why? Okay. So what happens if you are connected to a flash drive and you're going through and having it write on your flash drive? You may say file save, and it may be saving onto the flash drive, but then you go to do something else. Depending on the speed and the size of the file, it can take longer than it normally, what you would think. And then if you just eject the flash drive or pull it out, not even eject it, it may still be writing in the background, and that's when you're going to get corrupted files. So you always need to make sure that you go through and you eject the USB type, and then you would go through and then it would make sure everything is going to be reset on there. Did you guys know that's the important part of doing it? Okay. So lots of people have had corrupted files. Let's go ahead and try 4.2.3, installing a USB device together. That should go relatively fast.